Hi everyone. Let's start this session with a number. And this number is 72%. And guess what it is? 72% is the number of manufacturing companies that are in the process of implementing their Industry 4.0. So by this number, you can guess the big interest around this topic, the Industry 4.0. I'm Julian Bertolini, and today I will talk about Industry 4.0, but moreover, I will present you one of concrete example of an Industry 4.0 implementation. So I'm working as an IoT expert at Volvo. So I'm in the IoT domain for more than a decade. And let me jump to the topic and to show you this concrete example. So first at Volvo, the Volvo Group, we are not a car manufacturer. The Volvo Group is one of the leaders to manufacture trucks, but we are doing also buses, some construction equipment, and some engine for the boats. So let's start with a little bit of context. So what is the Industry 4.0? So I'm going to be really quick here, but everything started, the industry started with production mechanization that were using water and steam power. And then come the electricity. So it's at the beginning of the mass production. And we can think, when we're thinking about Industry 2.0, we can think about Henry Ford, who was a big innovator at this point of time. The third revolution is the digital revolution. So we are in the Industry 3.0 currently with all the numerical control. We can talk about the PLC, the programmable logic controller. Also the enterprise resource planning, all the IT in the factory. And today we're going to talk about the Industry 4.0. So what it is, so first it's a bunch of new technologies. So of course we can talk about IoT, the Internet of Things. I love that because I'm an IoT expert. But there's also other technologies like 3D printing, like all the immersive technology with augmented reality and mixed reality. We can talk also about artificial intelligence, about drones. So we have a lot of new technologies that are transforming our industry. But mainly, the Industry 4.0 is also about customer needs. So it's driven by two things, the new technologies and the new customer needs. And what are these new customer needs? So basically, the industry should be able to produce faster with highly customized products and at a good price. So that's the three challenges for the Industry 4.0. So now you got what it is and what are the challenges. So let's jump on how to do that. So the vision for the Industry 4.0. So we can summarize that in 4 pillars. The first one is the flexibility. So our production line should be flexible. So it means that with the same production line, we should be able to create different type of product. That's a big challenge. Second point is the reliability. So in order to meet the challenge, we have to have a really high availability of our equipment. A good performance, of course, and here we can measure, for example, the OLE, the overall labor effectiveness, to measure performance. And the last pillar is the monitoring and the traceability. So we can call that digital twin or cyber physical networks, different buzzwords, but the main idea is to get all the data on a computer and on databases in order to really understand what happened and moreover what will happen. So you have now the context, the vision, and as I told you, we're going to jump now on a concrete example. Because at Volvo, we have a big program called Volvo Smart Factory. And basically, that's a big project to move our industry from Industry 3.0 to Industry 4.0. And the first implementation is in Sweden. And this implementation is for producing sinking ring. So the sinking ring is this kind of part. And it's a really important part because here you need this part in the gearbox, basically to synchronize the torque of the engine with the rest of the gearbox before going to the wheel and to the axles. So that's a pretty technical part, and we are producing different kind of part like that. And the target for this new line is to produce 215K units per year. So that's a big production. That's really ambitious. And we have decided to rise this challenge to implement an Industry 4.0 assembly line. So as I told you, the first pillar for the Industry 4.0 is the flexibility. So how we have done that? So flexibility, if you can think about different kind of assembly line. So first, before the assembly line, before Henry Ford and all these great innovators, there was just a single individual that would produce the parts by handling all the operations. And so it was highly flexible, but not efficient at all. And then with the mass storage, we know how to produce high volume lines. So basically, it's a line to produce standard parts in a very efficient way. So it's really efficient, but it's not flexible at all. You have to produce just a standard part or a standard product. Now we can see in a lot of our industries what we call the conventional line setup. And what it is, basically, a conventional line setup is a kind of high volume line, but with some customization. So you can produce several parts, but it's always a compromise between flexibility and efficiency. So you have to always make some compromise. The new way, the Industry 4.0 way of building assembly line is really different. So you are building a line. It's not a straight line. It's more a work center, with different cells. So as you can see in this schema, so basically the product will go from one cell to another, and all the product will not follow the same path. So it's really flexible, and you can add cells or you can remove some cells, and you can also manage the redundancy. So keep that in mind. I will show you concretely what it is in few seconds. Just one word I forgot to tell you is the asynchronous. Here, the work is asynchronous because you don't need to have a takt time with a fixed cycle time. The product can go from one cell to another depending on the cells available. So the cycle time is not fixed. It's asynchronous, and it's really agile. About the other pillar, I told you about the reliability. So how can you be really reliable? So of course we have to do some redundancy of critical equipment, and I will give you some detail. You need also to be able to do predictive maintenance. Otherwise you will not be reliable enough. For the performances, we have chosen to put some autonomous, the production need to be autonomous. So you will see about the transport that are using AGV, so automated guided vehicle, but also the quality inspection is automatic. Also tool management is automatic. I will show you that in detail. And the last pillar is the monitoring and traceability. And for that, you need to have an interconnection of all equipment. So all the cells should talk together. And for that, we are using some edge computing and some IoT platform. Okay, so let's go. Let's go to see the implementation. So this is the implementation of this sinking ring line. So here you see different cells. So there's 8 cells. One is called the repacking cells, and then we have 2 turning cells, 4 skiving cells, and 1 measurement cell. So how does it work? Basically, you have this AGT, so that's an automated vehicle, automated guided transport, that is bringing some pallets of raw material to the repacking cell. The repacking cell is taking the raw material from the pallets, put that into some rack. And here an AMR, so an autonomous mobile robot, is taking the rack and bring them to the first available cells. And then it goes to another cell. So the first available cells. So by this way, the product is moving from cells to another, and then the AMR take back the finished product to the repacking cell. The repacking cell puts the finished product to a pallet, and the AGT is taking back the pallets of finished products. So it's fully autonomous. So what do we have? We have some cells. We have also, as I told you, some autonomous vehicles. So we have 4 AMR like that. So here you see that's a mobile vehicle that is bringing the rack with some sinking ring. We have 1 AMR for measuring. So this guy is able to take apart and bring it to the measurement cell. And we have 2 AGT like that. So that's this kind of vehicle can transport pallets. Now I will show you a quick video. So please be really focused because it's less than a minute. It's really short. Okay, so let's go to the factory. So here you can see an AGT. So it's transporting a pallet and in an autonomous way. Here you see an AMR that is also transporting a rack of sinking ring. This is a skiving cell. So skiving cell to produce the parts with some. And here you can see the measurements AMR. And all these cells are sending the data to our MES, Optimity, and to our IoT platform, which is ThingWorks, in order to monitor and to have the traceability. So that was really short, but here you have seen a concrete example of the Industry 4.0 implementation. So what it looks like, if I take a look at the IoT application, I can see some screens like that. And what do you see here? Basically, you see each cell with the stack light. So by looking at the screen, you can see exactly the same thing as if you were on the line. You can see the status of each cell. And here everything is green, so it means that the line is working properly. Everything is working properly. You don't need any maintenance. If you click on, for example, on the repacking cell, because you want some detail about the repacking cell, you can see here the 6 storage area. You can see a lot of detail about each area. For example, the part number that is producing, the number of item in the pallet, and if it's an inbound or if it's an outbound storage area. So some info about it. So it's for real-time monitoring, but you can also see some production KPI. For example, this is an example from last week. So last week we have produced 4,500 parts, and with an OLE of 30% for this type of part, 67% for another part. And here you can follow the cycle time, and we can see what happened here on these charts. So two type of parts were produced, and we can follow the production. So I hope you enjoyed this quick presentation. If I have to see the result of what we have done of this implementation, I will summarize it by saying that first, for the high performances, the challenge is done, because the target of 250K parts per year is okay. We are producing at this pace, so we are really proud of that. But the flexibility, so we are able to produce different type of sinking rings. So that's also a great thing about this line. It's a really reliable production line. You know, the maintenance team told me it's robust and simple to maintain and to upgrade. So we are really proud of that. That's why I put this quote. And finally, I would say it's really data driven, because we can see that we can real-time monitor all the line, and all the data are centrally stored. So it's like really easy to have a great overview about what happened on this line. So what are the next steps? The next step is first some enhancement on the existing line. For example, we know that the AMRs, or the autonomous mobile robots, the tracks is not optimized. So we would like to do some optimization, some other little enhancements that we can do. And definitely that is a great example to build new assembly lines. So little by little at Volvo, in the Volvo factories, we will build new assembly line by following the same principle. And the long-term target is to have all Volvo factories, so all the lines in all Volvo factories in this Industry 4.0 mode. So we have 144 factories at Volvo. So it will be a long journey, believe me. So let me give you some key takeaways before ending this presentation. So the Industry 4.0 will bring us some agility. So we will be more flexible, and by being more flexible, we can accelerate the response to customer needs. It brings also an increase of efficiency in the production. So all the production KPI will be better with the Industry 4.0. Same thing for the quality. By having an automatic quality inspection, it gives us a lot better quality assurance. And then last but not the least, is more potential for innovation. Because if you think about having a production line in cells, you can easily modify one cell or duplicate another cell, or you can reorder your process really easily. That's the beauty of this new way of doing the manufacturing. So I hope by seeing a concrete implementation that you have a better understanding of the industry 4.0. Thanks a lot.